This is Alex, and he will talk about AI agents. He's a computer vision and MLOps engineer at ZenCoder with over, I think, 9 years of experience with shaping the future with AI-driven software development. Currently, he's a team lead of MLOps team at ZenCoder. So please thank him.
Okay, thank you for the introduction. So as computer vision and MLOps engineer, I won't be talking about those things today. I will be talking about AI agents and how they can help you as developers to work faster, better, and solve tasks easier. But before we go into the AI agentic world, can I get a show of hands from people who actually use any coding assistants right now, like GitHub Copilot or quite a lot. So those who don't, I guess, work in the insurance companies that don't allow such things. But out of those who use any assistants, do you use anything else other than Copilot or ChatGPT? Can I also get a show of hands? Okay, so I guess most of you are using Copilot. Okay, got it. Right, so just to make sure that we are on the same page, let's first talk about coding assistants and what their promise is. So usually you get a bunch of features, but they can be grouped into those 4 main categories. So you first of all obviously get code generation. It can come in different flavors. So you can basically ask natural language form to generate something, or it can be in the form of code completion. But either way, the idea is that you get the code from scratch. So you didn't have any code before, and as a result of those features, you get the code which you might or might not use in your code base. Then there is also code refactoring or code editing features, which basically allows you to edit your already existing code. There is some assistants also provide things like error detection, which essentially tries to fix any errors, well, detect and then fix any errors in your code. It, again, can be either in the form of natural language request, or it can be just a button which does some sort of magic behind the scenes. But either way, it suggests you some sort of errors which you might have, security vulnerabilities and so on, and that might suggest you the fixes. And then last but not least is, of course, things which are not directly related to code, but to the code itself, but things around the code, so docs generation. So usually code assistants provide features to generate code, to generate doc strings or to generate documentation, which is, of course, also a nice thing to have. So in general, those tools promise that you will start working faster, you will start to solve tasks faster, smarter, and so on. But unfortunately, the reality is not that great. So sure, you can tap, get a bunch of code, which you might spend a couple days trying to debug and understand what the hell AI even wrote to you. So yeah, that's unfortunately the sort of other coin of using the tools. And there was actually several studies on whether tools like Copilot actually improve productivity of the developers. And for sure, there are some benefits of using Copilot or other tools, for that matter. And some potential advantages are, as I mentioned, faster task completion, or also developers reported that they feel more confident about the code. They feel that this improved their performance. But unfortunately, if you look on the longer scale, on the longer time scale, you will see that code churn rate or code renewal rate actually doubled. So in the period of 2 weeks, around half of the code which was generated by assistants would either completely removed or rewritten or refactored and so on. And a lot of code completions or code generations also required a lot of intervention from the developers, which, if you think about this on the longer scale, doesn't really save you time, right? So you might feel like it's saving you time in the short span, but then couple weeks later, you would need to spend much more time on debugging the code, fixing it, or even just removing it, so all your efforts were in vain. Now, why is this happening? Well, First of all, those assistants are usually working using LLMs or large language models. And LLMs are trained to essentially predict the most probable next symbol or token. So let's say you start typing CLA, then the most probable next symbols would be SS, because class is pretty common word in the programming language, right? And this is good as long as you doing something which the models were trained on. And those models are usually trained on open source data, so as long as you are trying to type to code something which was seen in the open source data, you're fine. But then as long as you start deviating from that, as long as you're starting to, I know, for example, use your internal libraries in your company, LLMs start to fail. And that's basically because, so let's say in the open source world, for example, Jest is the most common framework. And if you start to use Mocha, right, the LLM would fail because essentially it will still try to predict Jest because it is just the most popular language. So if you're using Mocha, or even if you're using some sort of internal tool, internal framework, those models don't know anything about those frameworks, so they will probably they will basically fail and won't be able to help you with your own company-related tasks. But that's not the only problem. LLMs also tend to struggle with logical reasoning and utilizing several known facts or things which might be worded in a slightly weird way. So, for example, the phrase like Tom Cruise is a mother's son. It does sound a bit off, but it's still completely understandable for humans. Unfortunately, for LLMs, such phrases can essentially confuse the hell out of them. And so, for example, in this case, GPT-4o1, which is supposed to be one of the best models right now, it's actually pretty much failed to essentially repeat the same thing which was written in the original message. And there were also actually some other screenshots you can find there. It says like, oh, that's actually the boy's grandfather or whatever else. And so yeah, even the best models can hallucinate, but it will take them a bit longer than the regular models. Another thing is that they lack grounding in the physical world. So what I mean by that is the models don't have any idea about your environment where you work in. So they don't have access to your laptop. They don't know what kind of tools you use, what kind of frameworks, and so on. So they basically can only generate the code from what they've seen, and it doesn't have any connection to what you actually have on your own machine. So basically, you can think about this as sort of like this 50 first date scenario, where you would just randomly pick a developer from the street, and ask them to solve a task for your company. You don't give them any context whatsoever. You just give them the Jira ticket, and basically just sit them in front of the computer and ask them to solve it. They might generate you a good code, maybe, maybe not, but still it probably won't, because they don't know anything about your company. They don't know about your internal frameworks. They will essentially produce some code which might not be really useful for you. So you might probably want to rewrite it. You might want to even completely discard it. So not very helpful. And basically, whenever you try to ask the coding assistant to generate something for you, you essentially repeat this task of picking a random person from the street and asking them to generate something for you without giving them any context. And obviously, of course, you might get, again, decent results if what you are doing is related to open source data or similar to open source data, but unfortunately, in enterprise world, it most likely will fail. And then another part, of course, as I said, they work well in distribution. So as long as you are inside this distribution, sort of, you are golden. But then once you get outside of it, you use some sort of internal frameworks, well, essentially you are doomed to discard all the code which LLM will generate for you. So how can we solve that? Now, before we answer the question, let me actually ask you, what do you think developers spend their time most on, like in their work? And it's not drinking coffee, so so any ideas, any guesses? Patterns, okay, searching patterns. I heard something about testing. Yeah. Well, understanding in general. So there was a study in 2015. There was the link on the bottom left corner, where they basically analyzed what people spend most of their time on, and 70% of the time it was understanding. And it can come in different flavors, as it was mentioned, like understanding the product requirements, understanding the customer requirements, understanding the code in general, like what is written in the repository. And actual editing of the code is only 5%. And yet, current generation of code assistants focus essentially on 5% of the work, completely ignoring all the rest of the 70%. Now, let's remember this picture. We will get back to it in a second. So, what can help us focus not just on the editing part, but on the whole picture, especially on the understanding? It's a thing called AI agents. So AI agent essentially is a software that performs tasks on behalf of the user. And this might sound pretty much like what code assistants do right now, but the main difference for AI agents is that they follow several design patterns or principles, if you will. And the good analogy was actually in GitHub's blog, pretty recent post over there. So essentially, if you imagine a robot vacuum cleaner, Roomba or whatever, which can only point you to any patch of dirt on the floor, it's not very useful, right? It will just probably annoy you, but not help you in any way. Now, if you think about Roomba or robot vacuum cleaner in general, it essentially consists of two parts: software and hardware. Right, so you can think of software as AI agent because it's essentially doing some sort of task on behalf of user. It's cleaning the floor. Now, how does it do it? Well, first of all, it has access to physical world, right? It can move around on the floor. It has also access to tools like brushes, wheels, and whatnot. It can also plan its route, so it won't just randomly walk around the floor. It will move in a specific pattern based on what it scanned. And those are actually the principles which agents in general would follow. So tool use, and in case of coding, it can be debugging, debugging tools, it can be web browser when you are searching something, and so on. Then also planning. Of course, when we doing some tasks, even subconsciously, we try to plan our execution of these tasks. So I will do this first, and this part second, and so on. There is also reflection. So we try to talk with our peers. We try maybe with ourselves and see if the plan we came up is good or not, if the code we came up with is good or not, and so on. And there is also another part which is not really part of Roomba, but in general, in the agents, you can have multi-agent collaboration, where several agents can talk to each other, can collaborate, can come up with some sort of special plan on how to execute the task, and then execute it. Now, if we now overlay those four principles with this graph, this diagram on what do people spend time on, we can see that, we already have tool use, right? So we use tools for editing, we use tools for, outside of IDE, we use tools when we do UI interactions. Of course, for the planning, we need to understand the code, so a big chunk of this diagram is related to planning, and of course, we also probably need to navigate through the code and whatnot. Of course, there is reflection, and for reflection, we also need to understand things. And multi-agent collaboration really pretty much covers the whole thing, because for people or for agents to collaborate, we need to understand what we are collaborating on, and we need to, on top of that, we probably need to use some tools, we need to search information, and so on. So as you can see, AI agents essentially, in a sense, similar to what you are doing as a person, as a developer, and they can use that to help you essentially be more productive, code faster, as the current generation of code assistants promise you. Now, let's actually do some coding on how we can use those agents already in your everyday life. So over here, I have two notebooks, and the code is in Python. Sorry about that, but that's actually the main language of AI nowadays. So you can't really do much outside of it. But the code itself is pretty simple. So in this case, I'm using OpenAI GPT-4o model, and we can essentially ask several things from that model, which you probably maybe tried yourself, and as you could guess, it will fail. So let me check if I have my internet connection. Yeah. So of course, OpenAI GPT-4 doesn't have access to real life world. It can ping the website. It doesn't have any access to my computer because, well, it just lives somewhere in the cloud. It doesn't have any access whatsoever. It does give me some advice on how to do that, right? So it mentions like this pip tool. It gives me the commands and so on. But still, it essentially tells me to do that job myself. So it also lacks the fresh knowledge. So for example, Node.js 23 was released, I think, in October this year, if I'm not mistaken. And of course, unfortunately, LLM doesn't have any knowledge about it. And well, the same about this conference. It of course doesn't have any knowledge about HipCon happening right now. Now, what we can do with that is essentially use this reason framework. Oh, sorry, React framework. React stands for reason plus act. And this essentially conditions LLM to perform tasks not just by straight generating the answer, but actually trying to kind of think through the task. And this React framework consists of several steps. So first comes the thought. So let's say, given the task, I need to perform those actions, and yada, yada, yada. Then there is actually the step of action, where LLM can take some action which you have defined for the LLM. Then the pause step is essentially for LLM to wait for that action to finish and get the results back to LLM. Observation is analysis of the outcome of the action, and answer is essentially giving you the answer from LLM. And it can go in the loop. If, for example, after the first observation, the information it gets is not enough, so it might get into the second thought. Okay, based on this, I will also need to do that, and so on. So this essentially can be realized in this sort of system prompt in a simplified way, right? So we essentially just telling the LLM to do exactly what I just mentioned. So you run in the loop, just output an answer, and so on. And I will be defining 3 actions which are available for LLM to use. So first one is ping, essentially like ping the website. Bash is for executing any bash command. And web search is essentially for executing the web search. And then there's example session. So me as a user, I ask how many islands make up Madeira. And Madeira is chosen because I live on Madeira. So the thought from LLM is, well, I should do a web search for Madeira. Then action will be basically defined as web search Madeira. Then the pause means that LLM will wait for the action to perform the task. And then hopefully we will get the correct answer that Madeira is made up of 4 islands. Now let's actually execute that code. And as I said, I have 3 functions which essentially will, well, first one will ping the website, second one will execute the bash command, and the third one will do the web search. In this case, I will be just taking the top result from the web search from Google, but of course you can play with it and advance it. So let's test, see if connection works. So yes, we have the ping for HipCon, we have the Python version from my machine, and we also have data about Serbia. So it came from this website. So it seems to be working fine. Now let's do pretty much the same thing, ask the same things which we just tried to ask LLM. So what's the response time for Google? As you can see, it went in the first loop. So the thought is, okay, so to get a response time, I need to perform a ping command. It essentially defined that I need to have the action as ping google.com. The actual command did execute, and we got the response from LLM, which actually corresponded to the actual real-life knowledge grounded in the physical world. Now, we can do pretty much the same to kind of give access for LLM to our own machine. So in this case, I'm asking what Python packages do I have installed. So the thought is, OK, let's run piplist. This is the result of running piplist. And then this is sent to LLM. So it will take a couple seconds, because the input is quite long. But it should give us, hopefully, in the end, the answer about the packages we have installed. And again, as you can imagine, it's not obviously limited to just Python packages. It can be literally anything you define as your action. So let's see. Yeah, so here's the answer from LLM. Because it has now sort of access to our machine, it can answer us the questions which we asked based on the actual scenario based on our own environment. Let's do the same with the Node.js. So this version 23, which was released half a month ago. Again, the thought from LLM is to, OK, I don't have any knowledge about this. I need to do web search. So I will call the action for web search. And yeah, so there is the link, which gave us all the information necessary for this version of Node. And let's scroll to the answer from LLM. Yeah, here it is. So here's the answer from LLM. Now it is aware of things which were not in its training data, but which are happening right now. And the same goes with the HipCon. And it can give you more precise, more up-to-date answers based on the real world, based on your environment, and so on. And the same goes with the speakers. We'll just Google our website, and we get the list of the speakers over here. I think, well, I can see my name, so it seems to be correct. So you can imagine that, obviously, those actions don't need to be just those simple ping or web search. It can be whatever you define. And you can also imagine that those actions can itself, on its own, be their own agents. So you can think of, for example, the sort of top LLM being a product manager, and it has on its own, in its disposal, backend engineer agent, front-end engineer agent, DevOps engineer agent, who work together to define the plan on how to execute the task, and then basically go execute it, then go back to the product manager agent. They analyze the result, iterate on it, and so on. So as you can imagine, it can become quite a branched structure of agents, hierarchy of agents, which you can get pretty easy and pretty fast onto your own disposal. Now, of course, you don't need to just always code those things up. There are some open source tools. Let me get back to my presentation. There are some open source tools which you can use. So yeah, and by the way, all of this code is available on the repository over here. If you want to try it out, play with it, and so on. But yeah, there are also, of course, obviously open source tools which will allow you to define your own agents much faster and easier, like SVE agent or OpenHands, previously known as OpenDevin. But also, there is a way for you to try agents out already without any hassle, without any effort. And yeah, so you can do that with us, with Zencoder. So we built our product on top of two main concepts, repo-grokken and AI agents. So repo-grokken basically allows us to give to LLM much bigger context. So we can use the whole repository as a context, compared to, for example, Copilot, which only works with open files. We can see the whole repository. We can use it as a context. Then AI agents allow us to interact with your environment and essentially not just generate the code, but also try to run it, try to compile it, and at every step, we try to fix any errors which might arise from this generation. So let me, if we again compare this to our 51st date scenario, in our case, essentially, even though you can still think about us kind of picking the random developer from the street, but in our case, we give them all the context which they need to solve the task, which we give them all the, all the information about your libraries, about your internal frameworks, and so on. So this already helps this random person to give you the better predictions, better results. But on top of that, again, because we have access to your environment, we know about your environment, we can also, as I said, compile the code, run the code, and see if it actually works, if it actually compiles, and if not, we will try to fix it for you. So let me show you 2 quick demos on how it works. So, for example, we have this unit test generation agent, which essentially generates the unit tests for you. Let me start the video. So again, if you used any other coding systems, you would probably remember that they would just start streaming the code for you for unit tests. In our case, we first start with unit test plan proposal. So as you can see, we define what test cases we want to cover. And of course, you can also add or edit your own test cases. Now, once we start unit test generation, again, we don't just generate the code, we also do a bunch of checks on top of the code to make sure it actually runs, to make sure the test actually executes. And in the end, you get the result, the code, which actually can run, which actually can work, and which you can just essentially git commit and git push right away. And of course, we also use those agents. For code generation in general, or code improvement, so code editing. So in this case, we can essentially ask our plugin, ask encoder, to rewrite this function or refactor this function to use a library instead of just to use a JWT library to handle this the tokens, which is called JWT in Python. So now, as you can see, we also repair suggestions over here on the top, on the bottom right. And now, once we are done with the code generation, we remove all the unnecessary imports, and now the code is essentially just a single line, which is much more readable, much more maintainable, and in general, easier to work with. Let me exit this. Okay, yeah. So yeah, we are available for you already to try this out. You can scan the QR code, or you can just go to our website, zencoder.ai. If you sign up, you get a free trial of 2 weeks for free. And yeah, that's essentially all from the presentation. We also have a booth on the ground floor if you want to talk about any features in more details. I will be happy to go through with you on them. I also have some colleagues who are actually developers who are developing this plugin. So you can ask any technical or any questions you might find interesting. And yeah, so that's all from me. I will be happy to answer your questions.
So there are already a few questions.
Yeah, I've seen one in the app already.
Does the LLM process the result of the agent's actions, or does it just return as it is?
So we basically give you, hide from you all the backend machinery. Essentially, you get as the end result, well, the code, the generated code. You don't need to tweak it. You don't need to explore it. You don't need to do anything. You just need to click a button and get the result. Right away.
Thank you. Next question is, how does an AI Copilot address concerns around data privacy and security?
Yeah, great question. And yeah, we of course take data privacy seriously. We don't store any of your code in our cloud. The only time when we need to use the code, we only store we only use pieces of the code relevant to your request. And once we did the inference, once we process the code, we discard it. So the only copy of the code is stored on your local machine. So we don't save the code anywhere. And yeah, we also undergoing some certifications like SOC 2 and ISO for those who familiar with those. But yeah, again, feel free to stop by on the booth if you want to get more details.
Thank you. The next question, how to ensure the company to introduce AI which understands its code base but ensure it won't leak?
Well, I guess it's kind of related to the previous question. But in general, I think more and more companies are starting to shift, well, first of all, towards the cloud, right, from the on-prem installations. And then also, in general, if your competitors use those tools, which allows its developers to work faster, to ship features faster to its customers, to its clients, obviously it would put you in the it would put you behind your competitors because your developers can't have the same pace of work as your competitors do. So I think in general, this shift is happening. And I think in a couple years, well, I wouldn't say all the companies, but I think even like banks or insurance companies would shift towards using those, allowing those features, even though it is indeed hard for some, more strict companies.
Okay, thank you. The next question is a little bit larger.
Okay.
Do you think using these AI tools as a paradigm shift in context of next level of high-level language, using human native language to prompt result in some programming language?
Yeah, I've seen this question. It actually kind of unlocks these my hidden slides over here, or hidden memes. So yeah, so there are kind of two sides to using AI or code assistants in general. Of course, you can see them as tools which will replace you finally, or whatever, however you want to see it. And well, maybe once they replace you, you can go to be goose farmer or whatever you want to do. But unfortunately, still, those tools do require, well, first of all, they need data, right? They can't just create the code from zero. And I think, in general, these tools would feel more like you becoming kind of manager of a lot of virtual developers, virtual juniors, and you would be able to just give them the task in natural language form, asking them to do, I don't know, solve this Jira ticket or whatever, just define the requirements, and then just controlling or overseeing their work. So I think in a couple of years, the job of developer would be more about, kind of social skills or prompt engineering, if you will, rather than, giving the introductions of coding in the natural language form, rather than just, typing the code as you do now. And yeah, sure, this probably will develop some new forms, like you've probably seen with the prompts, right? So there are some sort of tricks or hacks where you can get better results. So like, I will tip you $200 or whatever. And it can be seen already as sort of like evolution or some sort of form of new coding language. All right, and I think in the future, as I said, the more we shift towards this, towards the use of those assistants, we will see more and more this natural language form development. Like today, we have YAML developers, and being DevOps, I'm YAML developer.
Thank you for the answer and for the memes. We have time for only one more question, as we have lunch down there. So can you share examples of significant productivity gains achieved by teams using AI copilots?
Yeah, so there are, as I've shown, I think, on the one of the slides, there are some research which actually do show some improvements. If you think about the productivity of the developers themselves. But still, there are a lot of contradictory research on this topic. So there are, I think, a month ago, there was a research which showed that for some specific company, which had, I think, around 800 developers, they didn't notice any improvement in their productivity when they used Copilot. So essentially, they just didn't use any tools for 3 months, and then they switched to Copilot and started using that for 3 months, and they didn't see any increase in number of pull requests or shorter time to market and so on. But at the same time, other companies do report that they start building things faster, or especially if we're talking about some sort of small startups, small companies, people can build products, can build tools or features much faster just because Copilot or other tools can essentially generate the boilerplate code for you, and you can focus more on more entertaining or more creative tasks. And yeah, I think as we go more and more in the future, and I mean, Copilot I think was introduced 4 years ago, so we are sort of still in the beginning of this shift. So I think the more and more tools we get, the better they get, the better they become, the more information they will be able to use, the more like agents and or whatnot, the much better improvements we will see in the productivity or from the use of those tools.
Okay, thank you. I think that will be it. I think everyone is hungry, so thank you, Alex, for the presentation, and go ahead and eat.